Hello, Accelerated Math 7-8 students. This is Module 14, Lesson 2. And Module 14, Lesson 2 is called Linear and Nonlinear Expressions in X. Okay. Linear and nonlinear expressions in X. I'm sorry about the weird noise at the end of the last video. It was my cell phone. Okay, so our goal for today. Today we will learn the properties for identifying an expression as linear or non-linear. The question that I want you to be thinking about with this is, how do you know if an expression is linear or non-linear? Things to know. An equation is built by having one expression that is equal to another expression. So the thing that is the most important about this when you're trying to determine linear versus nonlinear is that you have to really pay attention to your expressions and what they're equaling. So if we look at this one, it says 5x, and then you take that whole thing and square it, is equal to x plus 3. Realizing that x in both circumstances are exactly the same value. Okay? And so an equation means that whatever is on the right side of the equal sign has to be exactly equal to whatever is on the left-hand side of the equal sign, and both of those happen to be expressions that mean the same thing. An expression in X is a math sentence that involves operations and variables. So 5x squared is an expression in X. The reason why we know that it's an expression in X is because it's carrying the variable x. X plus 3 is also an expression in X, and the reason we know that is because it's involving the variable x in this part of the expression. So understanding what makes an expression and what makes an equation is very important to identifying a linear expression versus a non-linear expression. Okay, and so what we're looking for is we're looking for things that are telling us what x equals. Practice time. There are expressions listed in the table below. Please sort them into two different groups. Okay, so let's look at these very, very carefully. This table is made up of lots of expressions. You'll notice there are no equations in there. There's only expressions. In this one, we have 5x plus 3. We have negative 8x plus 7/9 minus 3. We have 9 minus x squared. That one looks different so far. Okay. 4x squared minus 9. That one looks a little bit different. 31/100 x plus 7 minus 4 2/10 x. Okay. This one is 2/3 to the third power plus 1. Okay, that's interesting. That looks like an odd duck. 11 times the quantity x plus 2. Negative quantity 6 minus x plus 15 minus 9x. And then we have this last one that says 7 plus x to the negative fourth power plus 3x. So looking at all of these, with the exception of maybe this one right here, because this one is an odd duck kind of, but we'll get there. What are you noticing about all of the expressions? They have just a tiny bit of difference in between them. What is the exponent of the variable in this one? You said 1, you are correct, x to the first power. The reason why we know that it's x to the first power is because it's not listed, because x to the first power means x one time, right? So we only see 1x in here. This is a coefficient. This is the variable. This is what we call a constant because we're adding something on. In this one, we have just the variable x, and its exponent would be 1. But now look at this one. What is the exponent on that guy? It's to the second power. This exponent is to the second power. Exponent is to the first. Exponent is to the first. This one doesn't even have an x, but we do have an exponent. Okay. X to the first, x to the first, x to the first. Ooh, x to the negative fourth and x to the first. Okay. So what we're looking at here is I'm thinking that in group A, we should put all of the expressions that might have x to the first. And then in group B, let's put all of the variables that have an exponent to the second. Okay, so this would be 5x plus 3, goes on this side, negative 8x plus 7/9 minus 3. Nope, that one goes over here. 9 minus x squared. 4x squared minus 9. 31/100 x plus 7 minus 4.2x. That one we're going to skip for a minute. 11 times the quantity of x plus 2. A negative times the quantity 6 minus x plus 15 minus 9x. And then our last one I'm going to put over here, 7 plus x to the negative 4th plus 3x. Okay? Why do you think we grouped them that way? In this one, you're noticing that the x can only be one value, right? Raised to the first power. So if I told you that x is 2 in this one, then you would get 10 plus 3 is 13. But on this one, you see that you have x squared, and so something else is occurring, okay? And not to get too deep on this, but if you have, let's just think about this for a minute. If you said the x was 2, like we did over here, what is 2 squared? 4. 2 squared equals 4, yes? Okay, but here's the other issue. What if I told you it was negative 2? So what's negative 2 squared? Be careful. That means you have a negative 2 times a negative 2. Don't you still get 4? Yes. So the x could equal just 2, or the x could equal a negative 2. Do you see, whereas over here, x can only equal 2? Because if we put in a negative 2 here, that would be negative 10, and then plus 3 is a negative 7. You get a completely different answer. Whereas over here, x could be 2, or x could be negative 2, and you would still come up with the same answer. Watch it. So x is 2, you get an answer of 4. 9 minus 4 is 5. Negative x is negative 2, squared is 4. 9 minus 4 is 5. So you have two different options for answers when you're squaring it, whereas when you're not, you don't get two different options. So that's a big difference between the two, isn't it? And if you're able to see that, then you can come up with a definition for linear expression is, nonlinear expression is. So I'm going to say, remember our title says linear and nonlinear expressions in X. Okay, today we will learn the properties for identifying an expression as linear or nonlinear. The way that we tell a linear expression is an expression where the value of x equals only x to the first power. So there's only one value of x. Okay? And then nonlinear is anything else. So we can say is any expression where the value of x equals any exponent of 2 or more. Because look, we have x squared, we have x squared, we have x to the negative 4th, and that, I guess we have to put slash less, right? Because that's a negative 4, but because that's a negative 4, it makes the expression nonlinear. Okay, so linear expressions have the value of x when it's only raised to the power of 1, whereas a nonlinear expression is any value of x where the exponent equals any exponent of 2 or more. And then when we put the less in, that's if you have negative exponents. Negative exponents. So -2, -2, -1, -3, -4, because all of those would give you a different value also when you square them. Okay. So kind of an interesting idea. We're going to play around with it a lot more to get you more acquainted with it so that you understand it better. But just know that if you're looking at a linear expression, the value of x is always only going to have the exponent of 1. A nonlinear expression is going to be where the variable has an exponent that is equal more than 1 or less than 1. I guess that's a better way to say it. More than 1 or less than 1, not equal to 1. Linear is equal to 1 in the expressions. Nonlinear is either more than 1 or less than 1. Okay? All right, so how do you know if an expression is linear or nonlinear? The variable, in order for it to be linear, the variable can only have an exponent of 1, and everything else that has an exponent more than 1 or less than 1 would be nonlinear. Okay? And like I said, we're going to play with it and have some fun and practice. And that's all I've got for you right now. Talk to you soon. Bye.